Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Ray Bryant about poultry manure sheds. Poultry farms are often heavily concentrated in certain areas of the country. This can lead to excessive amounts of nutrient-rich poultry manure in manure sheds with no easy way to return it to the fields that need it most. This episode, Ray discusses recent research into how big these manure sheds can grow, how far manure has to travel to reach nutrient sinks, and how we can better balance nutrients in the future. Don't forget to listen to the end of the show for our student spotlight. We'll talk more about that in a minute, but before we dive in, we wanted to thank our sponsors, starting with Gasmet Technologies, the maker of the GT5000 Terra, the smallest portable FTIR multi-gas analyzer for greenhouse gas and environmental research. Measure carbon dioxide, methane, nitrous oxide, ammonia, and water vapor in real time simultaneously from static or automated chambers and ruminant emissions. Visit www.gasmet.com, that's Gasmet spelled Gasmet, or email sales@gasmet.com for more information. Our second sponsor is Meter Group. Meter specializes in robust soil moisture sensing, innovative weather monitoring, cloud data logging, advanced data visualization software, and more. Their well-published scientific instrumentation is used worldwide in universities, research and testing labs, government agencies, agriculture, and industrial applications. Listen to their new podcast, We Measure the World, to hear how innovative researchers leverage environmental data to make our world a better and more sustainable place at metergroup.com/fieldlabearth. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Ray Bryant with us. Ray is a research soil scientist at the USDA Agricultural Research Service, Pasture Systems and Watershed Management Research Unit at University Park, Pennsylvania. Dr. Bryant received his bachelor's and master's in agronomy and soil science from Texas Tech University and his PhD in pedology from Purdue University. Ray joined the faculty of Cornell University as a pedologist in 1981. After attaining the rank of professor, he joined USDA ARS as research leader in 2001. He now serves as lead scientist for the Water Quality Project at University Park. His current research interests are in nutrient management and development of conservation practices to protect water quality, with a strong focus on the Chesapeake Bay. Dr. Bryant has published more than 100 peer-reviewed papers. He is a member and fellow in the American Society of Agronomy and the Soil Science Society of America, and is a member of the Soil and Water Conservation Society. Welcome to the show, Ray. How are you doing today?
I'm doing fine, Abby. Thank you.
Wonderful. We are so glad to have you today. So, today we're talking about manure sheds, specifically those related to the poultry industry. So to get us started, can you just define what a manure shed is for people?
Yes. A manure shed is the land area that surrounds a source of manure, where those manure, particularly the nutrients that are in the manure, like the nitrogen and phosphorus, but where the crops that are grown in that surrounding area can utilize those nutrients and then not be applied in excess.
Okay, and just to clarify, so I know watersheds are a very similar concept where it's kind of like where water will naturally flow within an area. So are manure sheds the same way, where it's just where those nutrients would naturally move in an environment, or does that include places that like a farmer might manually put them, even if it was, for example, like uphill from a manure source?
Correct. We're talking about transporting manure from the barn, for example, or the pit where manure is stored, transporting it out onto the land and to crop areas where it is needed.
Okay. Yeah, and we'll get into that transport element more later, so I'll ask some of my subsequent questions then, I think. So another thing that I just wanted to clarify for people, because we'll probably be tossing these terms around a little bit today, is broilers, layers, pullets, and turkeys. So can you tell me what those terms mean in the context of the poultry industry?
Yes, those are different kinds of birds. Broilers are chickens that are grown for meat. Layers are hens that produce eggs. Pullets are young hens before they're old enough to lay eggs. And then, of course, turkeys are raised for meat. And this is important because of the way that they are raised, the way they're housed, etc. And that affects the characteristic of the manure that they produce.
Okay. This is, I usually have at least one like really dumb question per interview. Turkeys, is that referring to like roosters, or is it like specifically like the bird a turkey?
It is the bird, the turkey. It's what you have for Thanksgiving or Christmas.
I wanted to clarify because I didn't see roosters in the list, and I just didn't know if they were like, oh, we just refer to like any kind of male bird as like a specialty turkey term or something, or if I was just completely misunderstanding. So as I said, we're talking about manure sheds today. So a lot of your research for this particular paper was centered around these manure sheds as they relate to specifically the poultry industry. So can you tell us as a bit of background, like how is the poultry industry structured and how that kind of affects these manure sheds just as it is now?
Yes. 50 years ago, a farm might include a family with some small acreage, 50 to 100 acres of land, and they might have a few cows for milk, some chickens for eggs that they could sell, or some birds that they could sell to be eaten, or some turkeys. And so the farms were very integrated, and the manure that these animals produced could go back out onto the land on that same farm. But today, animal production, and it's not just poultry, but dairy, beef, swine, they're all produced on large specialized farms that know how to produce those animals or those animal products most efficiently. And there are some efficiencies to that type of a system. However, what that leads to then is that feed is produced in, say, the Midwest and is transported to where the birds are grown. I'm in Pennsylvania, but I do a lot of work down on the eastern shore of Maryland. And there are a lot of poultry houses down there for broiler production. They're meat birds, and there are they're facilities that processing facilities down there. So they locate these specialized poultry houses close to those processing facilities, and they move the feed into these houses. In fact, there are some houses down there, some facilities we call 0-acre farms. The person that owns the poultry houses only owns the land that the houses sit on. They don't own any land where manure could be put out on the field to grow crops. And that is a very specialized type of production. And so that's kind of the way things are done today. And I guess beyond that, you're probably familiar with companies like Purdue, Nestle, let's see, what are some of the others? Smithfield. Those are big names in poultry production or milk production, depends, and Smithfield and swine production as well. But those we call the integrators. They basically contract the farmer to grow the animal products, in this case we're talking about poultry, to certain specifications, and then basically they deliver the chicks, for example, to the chicken farm. The farmer grows them to their specifications, and then they come pick them up and process them. So that's basically what our modern animal agriculture is like today.
So this specific project, you were kind of trying to figure out how to get those nutrients that are produced by these animals to where the crops are grown, right?
Correct. We're really kind of did a budget type analysis, where are the manure nutrients being concentrated and where they're produced. And then if you consider the land area around them, the manure shed, so to speak, how much land is needed to utilize all of that manure that's being produced in these concentrated areas.
Sure. So to start off, you were kind of doing your initial research analysis into this. You were trying to find these manure sheds, identify them, and identify sinks and sources of manure and those nutrients. So can you tell us a bit about what that process was like, of how you went about identifying all that?
Yes, and I like those terms that you use, sinks and sources. Of course, the source is the animal production facilities, in this case a poultry house, and the sink is the land where those nutrients are needed. And so what we did, we used ag census data that tells us how many animals of any kind. In our case, we're interested how much poultry is produced on a per county basis. And so we made some simple assumptions of how much a bird produces, how much manure a bird produces, did the multiplication, and that tells us how much manure is produced within that county. Same thing with crops. The ag census tells us what crops are grown, how many acres of it are produced, and then we do some assumptions about how much nitrogen and phosphorus is needed by that crop, how much is removed by harvest, and then we can calculate how big a sink we have. How many nutrients could be applied to those crops. And so it's kind of a budgeting process. So at a county level, a county becomes a source if there's more manure nutrients, nitrogen or phosphorus, that's produced in that county than there is land to utilize those nutrients. So that is a county that is a source. A sink county is one that has a lot of cropland and doesn't have very much manure produced in that county. Therefore, you could take excess manure from the source county, transport it to the sink county where those nutrients are needed.
Okay, that makes a lot of sense to me. For the ag census, can you tell me more about what that is and how long, program or project maybe, how long that's been around?
The Economic Research Service within USDA conducts the ag census every 5 years. So we used the most recent survey. I think it was 3 or 4 years old at the time, but that was the most recent data that we had. And we based our calculations on that information that we got from the Ag Research Service.
Yeah, that was a very cool part of this paper. I didn't realize that was a thing that existed, so that was kind of a cool aspect of your research that I really liked. So then, this kind of comes back to a question I had when we were talking about the definition of a manure shed, is you were then trying to kind of calculate the transport distances in order to get those nutrients where they need to go versus, obviously other factors that, the practicality of it, the cost of the transport, things like that. So how did you go about calculating those distances, and how do you define the limits of a manure shed if it's kind of just wherever you can take those specific nutrients? How do you set those boundaries?
Well, we kind of start in the middle of what looks like a concentrated area of source counties. And then we start moving that manure to the nearest sink area. And then when that sink area is satisfied with the nutrients that are needed for the crops in that county, then we have to transport it over to the next nearest county. And we keep moving out like that until we can find an appropriate sink for all of the sources in that vicinity. So it becomes quite broad. In fact, we were really surprised when we found out that if you just look at the source of poultry manure in the Southeast, starting from southern Pennsylvania down through the Carolinas, Alabama, Mississippi, on into Arkansas and eastern Oklahoma and Texas. That was what we called one mega manure shed, because there's enough poultry litter and nutrients in that poultry litter to satisfy the crop needs through that entire region. If you could just move those nutrients, you really wouldn't need any extra fertilizer.
Wow, that's huge.
Yeah, we were shocked.
Hi everyone, I hope you're enjoying the show. Interested in learning more? Ray's paper, Poultry Manuresheds Management, Opportunities and Challenges for a Vertically Integrated Industry, is always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Thanks again also to our sponsors, Meter Group and Gasmet Technologies. Meter specializes in robust soil moisture sensing, innovative weather monitoring, cloud data logging, advanced data visualization software, and more. Their well-published scientific instrumentation is used worldwide in universities, research and testing labs, government agencies, agriculture, and industrial applications. Listen to their new podcast, We Measure the World, to hear how innovative researchers leverage environmental data to make our world a better and more sustainable place at metergroup.com/fieldlabearth. For Gasmet Technologies, the GT5000 Terra is a robust and portable multi-gas analyzer for fieldwork weighing 20.7 pounds. The GT5000 Terra is splash-proof IP54 rated with an internal pump and battery, and instantaneous readings of up to 50 gases at sub-ppm concentrations. Check out the quick setup guide and learn more about Gasmet Technologies at www.gasmet.com and the links in the show notes. Thank you for being our sponsor. Let's get back to the show. What else did you find in doing this research?
Well, what I described, although it seems possible, it's not entirely feasible, because some of those transport distances from sources, after you leapfrog some counties that are sinks that are already filled up, you might be talking about transporting poultry manure 65 miles or more. In the southern Piedmont, down in Virginia and Alabama, there's just so much poultry litter being produced, or poultry manure being produced, that you've really got to move it a long distance, and that's not very feasible economically. And it gets worse. We focused on poultry, but I'm talking about an area that includes North Carolina, which is a concentrated area of swine production. Now, they've got the same issue, or you could look at swine manure with a manure shed viewpoint. In other words, let's move the swine manure that's produced to area that needs it. And if you do that within this area of the poultry mega manure shed, then you have to move manure sometimes 150 miles. So that's not feasible. And yet, the nutrients, the nitrogen and phosphorus in the swine manure, are equally good fertilizers and can satisfy the crop needs equally as well as poultry. So it gets very complicated when you start talking about multiple species.
Sure. Okay, I have a few questions off of that. Hopefully I can remember all of them. So, can you tell me about how is this manure transported? I think a lot of there's a variety of ways that manure is handled in agriculture and processed. So, are we talking about trains, liquid versus dry, trucks? What are we looking at here?
Well, poultry is poultry litter that comes out of a broiler house, those birds that are raised for meat, is relatively dry. It has some moisture content, but you can move it around with a front loader on a tractor and load it into a truck, and then you can truck it somewhere where it's needed and dump it. And so by its nature, it being relatively dry, it's fairly easy to transport. Now, swine manure, by contrast, is liquid. It's just the way that they handle the swine. It goes out into a big tank or a pit, and it's liquid manure. And so it's not very feasible to transport liquid manure. We have liquid dairy manure in Pennsylvania. We just use a liquid kind of flush the barn to get the manure out. And so our dairy manure is very liquid. And so it's not feasible to haul that liquid manure very far. Out west, dairies are open lot dairies, and their manure is relatively dry. So you're right. The feasibility to haul manure depends very much on the characteristic of the manure. How dry is it? And that if it's dry, then it's more feasible to transport it.
Sure. And then my other question is, we talked about these different kinds of birds, and then obviously swine and dairy got pulled in. So I'm curious as to how specifically with poultry the nutrients that are in the manure are affected by the kind of bird, because they're eating basically the same thing, sort of. Maybe not if they're trying to encourage different aspects of the animal to come to the fore. So how does that all work between the crops that they're fed, or what specifications they're being grown to versus what is going to be in the manure that they make? How does that factor in?
Well, there is not a lot of difference in the characteristic of pure chicken manure. Little difference if you talk turkey versus chicken. But if you're talking broiler versus layer, the pure manure that comes out of the bird is very similar. The difference comes in the way that the bird is housed and the way that it's raised. Because broilers that are raised for meat are in these big open houses, big open floors, and they usually have sawdust down on the floor. It's kind of their bedding, so they can scratch around in it, and it keeps their feet dry because it absorbs moisture that comes out of the manure. But layers are generally not in that kind of environment, and the manure that comes out of a layer is relatively pure. So the nutrients are more dense in that pure manure out of a layer facility, whereas they're somewhat diluted by all of this bedding, sawdust and wood chips that's used in the bedding is part of poultry litter. And, once it comes out of the barn, you can't really separate it that way, so you just have to deal with it. But what is the significance of that? One aspect of this whole issue that we need to get into is processing. If we can make those nutrients more dense, or somehow maybe get them into a form that's more easily transported, then it's more feasible to do what we're talking about in a manure shed and get those nutrients back out to land areas and sink areas where they're needed. For example, you can pelletize this poultry manure. If you pelletize broiler litter that contains sand, sometimes there's wood chips and sawdust, and sometimes there's sand in there. Purdue is one of the big integrators, one of the companies that contracts farmers to grow their birds. They set up a pelletizing plant on the eastern shore of Maryland, and they pelletized that poultry litter and then shipped it great distances because it was an easily handled product. It didn't smell, so homeowners could use it in their gardens, and so it was a more valuable product after they pelletized it. But the impurities in that litter wore out their pelletizing equipment, and it's more feasible to pelletize what comes out of a layer facility because it's cleaner, it's more pure, the equipment lasts longer. And there are a number of pelletizing plants across the country, but they're more successful when they're trying to pelletize layer manure because of its basic characteristic compared to broiler.
Wow. Yeah, I wouldn't have thought that it would make like that big of a difference for the equipment, but yeah, I mean, if you think about it, adding wood and sand into your mechanical equipment is definitely going to make a difference over time. Yeah, so then there were a few other aspects of this that you were looking into or maybe are on the horizon. So obviously we mentioned already having to accommodate overlap between different types of animals that are being raised, maybe some of the quality between the different types of fertilizer. And then also just, legacy nutrients that are in the soil. So can you talk about some of those compounding factors and either what you found or things that need to be taken into consideration when approaching this issue?
Yes. We mentioned things like 65-mile hauling distance or possibly 150 miles, which, those distances aren't very feasible. But they're based on the nutrients that a crop could utilize or the nutrients that are removed by growing a crop. The complicating factor is the legacy nutrients that you mentioned. That term means, how much nutrients are already in the soil because maybe manure has been over-applied for many years and just hauled out of the barn, put on the closest field. Well, that field has built up with really high nutrient levels, and so you really don't want to put any more nutrient on that field, at least not phosphorus. Nitrogen tends to disappear. It gets lost into the environment, unfortunately. But phosphorus can build up, and then it becomes a problem, an environmental problem. It degrades water quality, and that's where this original study and the interest in it came from, is the impacts on water quality. And so ideally, if you have high phosphorus in the soil, you kind of want to just grow crops to remove that phosphorus and get it back into a better environmental balance. But we didn't have that kind of data. So we know that there are areas within our mega manure shed where we really should not be putting any additional manure. And that just makes the problem worse. Those areas are known locally, but they're not known to us when we're doing like a national kind of assessment.
Sure. We've talked about a lot of the complications in this, obviously, and how some of this just isn't currently feasible. But I think, we want to have like a positive outlook and look to how we can make this feasible. So my next question is kind of about your future research in this area. And that could be both as to the data and knowledge on the sources and sinks. It can be, how we can improve the transport or maybe innovate how we get things from farm to field. And then also kind of looking at the poultry industry at large, are there possibilities to spread things out a little bit, or is that not the way to go? Can you just talk about what are some of the opportunities that are ahead to rebalance the fertilizer scales a little bit?
Well, I think you've done a very nice job of identifying opportunities to address the problem that we have at hand today. It's all of the above. We can work to improve our infrastructure for handling and moving poultry litter, which is in more like a dry form and better suited for transport like that. We can improve technologies for treating manure at the production facility. Swine manure can be chemically treated to remove phosphorus. Liquid dairy manure can be filtered to remove phosphorus and get it into a dry, solid form that could be transported, similar to what poultry litter could be transported. So it's some of these technologies for treating litter. Also, in the application, there are some interesting technologies that deal with how you put the manure on the field. There is liquid manure injection technology, and that's really helpful because it reduces the amount of nitrogen that's lost from the system, so you're better utilizing that nutrient and less likely to lose it to the environment. So all the manure treatment, manure application, manure transportation, there's opportunities to improve the way we handle the manure. Also, some of the production is also geared towards, recognizing that concentrations of manure can cause environmental problems. And so the integrators are aware of that, and they sort of look to locate their production facilities in areas where there are nearby sink areas that can accommodate that surplus of manure that's produced at the facility. That's being done in Pennsylvania in the swine industry. So that is another opportunity as well.
Oh, that's very cool. I like all of that. Yeah, that's so great to hear. Good to see people are moving the ball down the field on this. Obviously a very important issue with a lot of potential environmental impacts and economic impacts and all of that. So thank you so much for your research. Thank you so much for your time today. I really appreciate it. I've got 3 questions left for you. So the first one is, if people want to learn more about any of the stuff that we've talked about today, what are some resources that they can look into?
Well, of course, there's our scientific publications, but a lot of people don't enjoy poring over a rather dry scientific publication, but that's where the information originates. that usually finds its way into popular press articles, and there are some popular press publications in the poultry industry, for example. And so if you want to find more about poultry industry, you'll find articles in there about all aspects of poultry, including how manure is handled. And that's true for the other animal sectors as well. There are a few YouTube type presentations that you can learn more about this issue as well.
Wonderful. Those are some great resources. We'll see if we can get some links for the show notes maybe on some of those. My next question is, if people that want to take the next step to get involved with solving this problem or conundrum, how can they do that?
Well, I think it's always good for the big companies like Purdue, Smithfield, Nestle, and the others to hear from the consumers. And they're always very interested in what the consumers have to say. And so just writing a letter to the CEO of a company and expressing your concern about this might help them. It will encourage them. And typically these large companies, they have environmental offices within the company that deal with these issues all the time. So they'd be interested in hearing about the consumers' concerns. Recently, I was contacted by the Office of General Counsel, and USDA has recently announced a $500 million grant program to address the current fertilizer crisis. And here we're talking about commercial fertilizers, which have gone extremely high cost due to the high cost of natural gas with global issues that are going on today. And how can the U.S. be more self-sufficient with fertilizer? And my response to them was, well, take a look at the oldest fertilizer in the world, that being manure, and look at how we can best utilize those nutrients that are sometimes being wasted or being lost to the environment, and include that in part of this need to address the fertilizer crisis. So that's kind of I think, a sign of optimism, I guess. A reason to be optimistic is that the government is also stepping up to try to address this, and I believe they will include manure as part of the solution to the current fertilizer crisis.
Great. Yeah. Always love to have an optimistic note. Big fan of that. Final question for you then. What is one fun fact that listeners would not know about you if all they had was your research?
Well, sounds like I'm a scientist that sits in an office and looks at statistics and does calculations and thinks about manure problems all the time, but I actually live on a 5-acre farmette about 10 miles outside of State College, Pennsylvania. And for the last 20 years, my family, my children as they were growing up, have raised horses, sheep, goats, chickens, ducks. We have fish in a farm pond, dogs, and cats. And I don't just do calculations and write scientific papers about manure. I get my hands dirty shoveling manure on a daily basis.
Well, that's a very fun fact. I like that a lot. Yeah. Well, thank you so much again for your time today. It's been a pleasure to chat with you, and thanks for all that you do.
Well, thanks to you, Abby, and thanks to the listeners.
Hi, everyone, and welcome to our Student Spotlight, where we highlight the work of graduate and undergraduate society student members. Today, we'll be talking to Rajveer Singh. Welcome to the show. Can you start us off by introducing yourself and where you're studying?
Sure. Hello, everyone. My name is Rajveer Singh. I am originally from Punjab, India. I work full-time as a research associate and pursuing my PhD part-time at Auburn University, Alabama, in the Department of Crop Soil and Environmental Sciences. It is my first semester and I'm excited for it.
Great. And what are you currently researching?
Currently, my research is investigating how clean-out frequency of boiler litter influence corn grain yield, plant biomass and nutrient accumulation, and soil chemical and physical properties. We are testing 3 types of boiler litter aged less than 6 months old, 12 to 24 months old, and 24 to 36 months old.
Awesome. And if you could have your dream research project, what would that look like?
Sure. I have been working with boiler litter for the past 4 years. It is a nutrient-rich source readily available in Alabama. However, it is bulkier and quite variable in its composition. My dream project would be to somehow transform this litter into a compact, concentrated commercial product, just like conventional fertilizers.
Great. Well, if you would like to get in touch with Rajveer about his work, we'll have his contact information in our show notes. Thank you so much for being on the show today, and best wishes on your future studies and career. Thank you.
Thank you.
Thank you for listening to Field Lab Earth. More information can be found in the description below. Thank you.